Section 9.5. We're going to talk about the, can't spell today. A-N-G. So lengths of secant and tangent segments. In circles. Now the important thing to remember about this section, in all the other sections we've talked about so far, we've been talking about the angles and the arcs, and measures of the angles and measures of the arcs, and comparing the angles and arcs. What we're talking about today is just lengths of segments. No angles, no arcs, just lengths. So today we're talking about lengths only. No angles or arcs. So all of our rules today have to do with lengths. All right, so our first one has to do with two tangents. So our picture for two tangents is we have a circle, and we have two tangent lines to our circle. And I'm going to label our point A, and we'll call this B for the vertex, and B. So if we have two tangents, we're talking about the lengths. When we have two tangents to a circle, our rule is AV equals BV. And our shorthand that we can think of as tangent equals tangent. So we're talking about this length being congruent to this length. So this segment is congruent to this segment. Tangent equals the tangent. And just very quickly, if we were going to prove this, if we wanted to prove this idea, what we would do is I would draw in two radii. And what do we know about the lengths of the radii?
They're the same.
They're the same. Radii are always the same. So these two are congruent. What angle do radii make with tangents? 90 degrees. So those two are right angles. Now I'm going to draw in one other helpful segment here. And now I have the hypotenuse of each of these right triangles. And the hypotenuse is the same for both triangles. It's congruent to itself. So now these two triangles are congruent by hypotenuse leg. So the other part has to be congruent. So to prove that, I draw in a radius, make two triangles. My circle problem turns into a triangle problem, and I can figure out that those two lengths are the same. So I have two tangents. The two tangent segments are equal. Questions on that rule? That one should be an easy one. All right. Our next rule is for two secants. So our picture for two secants, here's my circle. Move that over a little bit. my secant, we have a secant, two secant lines that intersect outside the circle. And we're going to label this, I'll call this A, C, and we'll call this B for the vertex, and B and D. Thank you. So when we have two secants that meet outside a circle, what we're going to say here is that AV times CV equals BV times DV. And our shorthand here is that the whole, this whole segment times the outside, this little outside piece, the piece that's outside the circle, equals this whole segment times DV, which is the little piece that's outside the circle here. The whole times the outside equals the whole times the outside. So when I have two secants, the whole times the outside equals the whole times the outside. And by the whole thing, I mean the whole segment made by the side of the angle where it hits the circle. And the outside is the piece that's outside the circle. Here the whole segment is this whole length here. And the outside is this little piece that's outside the circle. Whole times the outside is the whole times the outside. So let's look at an example using this rule. Actually, we'll look at a couple of examples. Start with an easy one. So here's our circle. Whoa. Here's our secants. Here are our secants. And we'll label this circle A, B, we'll call this V for the vertex, D, and C. And for this problem, we're going to say that AB equals 13, BV equals 6, and we want to find CV. And we know that DV is 15. All right, so let's label what we know on the circle. AB is 13. This segment here is 13. BV is 6. DV is 15. So that whole thing is 15. And we want to find CV, this piece here. If we don't know what that is, let's call it X. All right, so for this top line, on that top line, what is the length of the whole segment? What is it? 19. The whole segment is this piece plus this piece. So it's 13 plus 6, or 19. What about the outside? On the top line, what's the outside segment? The little piece that's outside the circle is 6. On the bottom line, what is the length of the whole segment for the bottom line? 15. It's the whole thing. How about the outside segment? How long is the outside segment? X, we don't know. We'll just call it X. So we're going to use whole times outside equals whole times outside. So 19 times 6 equals 15 times X. So this one's not too hard. 19 times 6 is 114. And that equals 15X. Divide by 15. and x equals 7.6. So this little piece is 7.6 units. Whole times outside equals whole times outside. So questions on that example? All right, let's look at one that's a little more complicated. This one is going to be a really important one to write down, because this kind of problem shows up often with these kinds of problems. So here are my secants, and let me label these. I'm going to call this B, A, we'll call this V again, D, and C. So for this problem, AB equals 13. AV equals 6. CD equals 11. And we want DV. All right, so let's figure out our pieces. We have two secants, so we're using whole times outside equals whole times outside. So on the top line, what is the length? Let's label what we have. 13, 6, CD is 11, and we don't know this. So on the top line, what's our whole length? Is 19 again, right? 13 and 6, this piece plus this piece. The outside. How long is the outside? 6? Just like the last one. Now on the bottom. So this bottom line. We don't know the whole thing. We don't know the outside part either. So what we're going to do is let's call this little piece X. So I'm going to call this little piece X. If I find X, I can add it to 11 and get the whole thing. So we're going to call this little piece X, add it to 11, and I'll get the whole thing. So for the bottom, how am I going to write the whole segment? X plus 11. I'm adding them. This piece plus this piece. So I'm going to say 11 plus X. The outside. How long is the outside segment here? X. It's just X. We don't know what it is. So we're going to call it X. So now we have the whole, the outside, the whole, the outside. Now I'm going to set my problem up. 19 times 6, the whole times the outside, equals 11 plus X. Put it in parentheses so I multiply correctly, times the outside. Well, 19 times 6 we know is 114. What do I have to do here? I have to distribute. When I multiply by parentheses, I have to distribute. I'm going to distribute the X. I get 11X plus X squared. My favorite kind of problem. So when I have an X squared, an X and a number, what do I have to do? You remember? PEMDAS, well, PEMDAS was kind of here. We can't take the square root because of this X. We have an X squared and an X. We have an X squared, an X, and a number. Everything on one side. Zero on the other. So I'm going to subtract 114 from both sides. So I get X squared plus 11X minus 114 equals 0. Now when I have an X squared, an X, and a number, and an equals 0, how do I solve problems like that? Anyone? factor or quadratic formula. So because we have this 11 and this 114, I think this is going to be kind of hard to factor. So we're going to use a quadratic formula on this one.
You have the negative.
Quadratic formula, you may need this in your homework. Negative b plus or minus square root of b squared minus all over 2a. So in our problem, a is the number that's in front of x squared, b is the number that's in front of x, and c is the number that's by itself. And this is x equals. So let's plug our numbers in. X equals negative b, negative 11, plus or minus the square root, b squared, 11 squared, minus 4 times a is just 1. There's no number here, so that's just 1. And c is negative 114. And we're dividing that by 2 times 1. This number is just 1. So I'll multiply this out. Minus 11 plus or minus the square root of 121. I have a minus and a minus, so I get a plus. 4 times 114 is 577. All divided by 2. Add these two together. Minus 11 plus or minus the square root of, whoops, I added too soon. 11 times 14 is not 577, it's 456. 121 plus 456 is 577. Divided by 2. There we go. Minus 11 plus or minus square root of 577, I put it in my calculator, is about 24.02. Divided by 2. If I take a minus 11 minus 24, I get minus 35 point something. Divided by 2, I get a negative number. So I can't have a negative length. So I'm going to add minus 11 plus 24.02. Divided by 2. So I get, when I add this and divide by 2, I get this is approximately, x is about 6.51. So this little length is 6.51. We were looking for dv, we were looking for the whole thing. So dv is 11 plus 6.51, which is 17.51. Yes? So yes, so the question was, could I call this whole length x and then call this little segment 11 or x minus 11? Yes, you could do it that way, and you'd end up in the same place. You'd end up with the same equation. I did it this way so we could add instead of subtract. All right, so quadratic formula. These types of problems where you either have to factor or use a quadratic do show up with this homework. So this is something that you'll need to be able to do. All right, questions on that example? But the rule was the whole times the outside equals the whole times the outside. That was our rule. All right, we have 2 more rules that we need to talk about. The next one is a secant and tangent. So our picture for this one, we have a secant, we have a tangent, and we'll call this C, this A, this B for our vertex, and this point B. So our tangent just touches in one place. So I have our secant and our tangent. Our rule for a secant and tangent, we're going to say that CV times AV equals BV squared. And the simple way to remember this one, whole times outside equals tangent squared. So this whole segment, just like in the last one when we had a secant, the whole segment times the outside piece equals BV squared. Whole times the outside equals the tangent squared. So let's look at an example using this rule. So here's our picture. There's our circle. Our secant and our tangent. And I'll call this point A, this point B, this point B, and this point C. And I'm going to say that BV is 24, CV is 30, and I want to know AB. So let's label what we have. This piece is 24. This piece is 30. And we want to know that whole piece. So what I'm going to do, let's see, no, this isn't what I want to write. What do I want to find? I want to find AB. I want to find this. So this piece that I want to find, let's call that X. So on the top line, what is the length of the whole segment here? 24 plus X. We have to add. The outside is 24, and on the bottom our tangent is just 30. So here we just have to worry about the one piece. So we'll use our rule, the whole times the outside equals the tangent squared. 24 plus X times the outside, 24, equals 30 squared. What do I need to do with this 24? I need to distribute. 24 times 24 is 576. And 30 squared is 900. So this one's not too hard. Subtract 576. I get 24x equals 324. Divide by 24, and x equals 13.5. So this little unit, this little segment is 13.5 units. Questions on that one? Now, because we have our tangent squared here, when we do problems that involve a tangent, sometimes they end up being numbers where or problems where we have to factor or use a quadratic formula. Because we're dealing with these x squareds, we're dealing with multiplying those, that shows up in these kinds of problems. All right, last rule for today. Intersecting chords. This one is different than the last three examples because our segments are intersecting inside the circle. So that's what makes this one different. In all the other examples, our intersection of the two lines or the segments were outside the circle. Here we're intersecting inside the circle. So here's our picture. And I'm going to have two chords inside my circle. Like so. And again, we're talking about lengths, not angles and arcs. So I'm going to call this A, B, C, and D. And this is our vertex, V. For this one, our rule is AB times VC equals DV times VB. And our shorthand here, to help us remember this, is I always say the part times a part equals a part times a part. So this piece times this piece equals this piece times this piece. So our chord, where they intersect, it divides it into pieces. I multiply the two pieces on one chord, and that equals multiplying the two pieces on the other chord. So the part times a part, or the piece times a piece equals a piece times a piece, however you want to think of it. So let's look at an example using this rule. So our intersection again is inside the circle. We're talking about the lengths of the segments. All right, so here's our problem. And we're going to call this D, A, B, and C, and we'll call this our vertex. Now we don't know that this is a radius or a diameter. The center of the circle is here. We don't know that that's a 90-degree angle. It looks like it might be, but we don't know for sure because the problem doesn't tell us that. What the problem does tell us is that BV equals BC, and both of those equal 10. AB equals 3, and I want to find AD. So let's label what we know. This piece is 10, this piece is 10, not drawn to scale. AV is 3, and we want this whole length. So what we're going to do is let's find this piece, let's find X. If I find DV, I can add 3 to it, and then I have the length of the whole thing. So we're going to find X, add it to 3, and then I get the whole thing. So our rule is the part times the part equals the part times the part. So on this line, one part is 10. On this line, the other part is 10. And that equals, on the other line, one part, 3, times the other part, X. 10 times 10 is 100 equals 3X. Divide by 3. X is 33.33. So this piece is 33.33. And I add 3 to it to get AD. So AD, 33.33 plus 3, or 36.33. Questions on that example? All right, so we learned 4 new rules today. Let's just go back and look at each one of them really quickly. These are all, again, have to do with the lengths of the segments. We're not talking about arcs, we're not talking about angles. If we have 2 tangents, the lengths of the tangents that meet outside the circle, the lengths of those 2 tangents are the same. Tangent equals a tangent. If we have 2 secants that meet outside the circle, the whole times the outside equals the whole times the outside. So that was our second rule. Our third rule was a secant and a tangent. They meet outside the circle. The whole times the outside equals the tangent squared. And our last rule is when we have 2 lines or segments intersecting inside the circle, we have chords inside the circle, the part times the part equals the part times the part. The intersection divides them into pieces. Multiply the 2 pieces on one line, and that equals the 2 pieces on the other line multiplied. All right, I am going to, let's go over our homework from Friday really quickly. And then I will put, why don't I put right now, just to make sure it's up there, our homework for today, page 606, number 11 through 28.